In this proposal, I present my idea of how I would make a space elevator as simple as it is possible to imagine. I will begin by describing how I would start the construction from the geostationary point, kilometer 36,000, until I reached the kilometer where I would locate the apex anchor, and where I would place the anchor on the Earth's surface. I dare to say that Panama would be a good candidate for the location of this space elevator. This country offers many positive qualities that make this project viable. We are close to the geographical equator, we do not have earthquakes or hurricanes, we are the air hub of Latin America, and it is not a simple coincidence that we have here the Panama Canal. First, with the help of astronauts, the construction of two assembly machines will begin, which will be located at kilometer 36,000. One of them will point towards the destination on Earth where the project will be anchored, in this case Panama. These assembly machines will be made up of a solid cylinder of a very resistant and light material about 8.5 meters long by 7.73 meters in diameter, which will be welded to the assembly machine, and as a reinforcement measure will have a fastening ring that will give it additional firmness to all parties. On Earth, sections of cable just over 250 kilometers long would first be manufactured, of a certain thickness and of a very resistant material that could be Xylon, graphene, or a similar substance that resists a large amount of weight in the space environment. These cable sections of about 250 kilometers long each, will be rolled into 5 special containers of about 7 meters in diameter and 1.70 meters high. Each end of the cables will be strongly welded to the original container and its other end to the next container, giving a total of about 1,000 kilometers long. These 5 containers that transport 1,000 kilometers of tether will be mounted on reusable rockets and will take the containers up to 36,000 kilometers. Upon arrival at GEO with the help of astronauts, they will remove the 5 cylinders from the rocket and they will be welded in the following way. The first cylinder of the new shipment will be welded to the last cylinder of the previous shipment, until forming a column of 256 cylinders stacked one on top of the other. Once you have a column of 256 cylinders, one stacked on top of the other, then you will braze one of the jointing machines to the start of the cylinder column. Important note: the astronauts are to scale to give an idea of the dimensions. From the surface of the Earth, the assembly machine will be fed continuously with 4 rolls containing 500 kilometers of tether made of graphene super-laminated or better quality. With the help of astronauts, each new shipment will be inserted into the assembly machine as follows. Each tether roll at its end will have a 50-meter-long layer of super-laminated graphene, and each new shipment will start with a cable that will be inserted within 50 meters of the layer of the previous shipment. The assembly machine, somehow, will weld each new shipment. It would be like inserting a foot into a sock. And the result when leaving the assembly machine would be a tether 36,000 kilometers long in which the joints between each section cannot be detected. In this presentation, the Roden C9 will be used on both ends of the tethers, both the Earth-facing end and the space-facing end. This is in order to create a balance between what is coming out of the assembly machine and the tether that is heading towards kilometer 100,000. Important note: when the Roton C9 is about to run out of fuel, they will simply be replaced with a new one at both ends. Simultaneously to the aforementioned process, on Earth, the construction of the tether anchor will be carried out, using two options. Option A, a structure similar to a nuclear silo, and Option B, a marine platform. In this video we will use Option A. In a continuous and controlled way, the Roton C9 will continue removing and stretching the tether of the 256 cylinders until completing the remaining 64,000 kilometers, that is, the 36,000 continuous kilometers of superlaminated graphene plus 64,000 kilometers made by the cylinders. As the downward-pointing end approaches the Earth, the Roton C9 will be exchanged for several multi-directional rockets, which are more resistant to impacts, to correct the trajectory towards its anchor point, in this case Panama. Important note: the multi-directional rocket will be provided with an airbag system very similar to the one used by the Mars Pathfinder in 1997. And upon entering the Earth's atmosphere, these will deploy to minimize any damage to the rockets. When the end of the tether reaches the surface of the Earth, it will be dismounted from the multi-directional rockets, and the end of the tether will be attached to a special anchor waiting for the next phase. Once the tether made of graphene superlaminated has been connected to the Earth, at the other end the 256 cylinders have had to be tensioned until reaching kilometer 100,000. Important note: to help the Roton C9 to stretch the tether to 100,000 kilometers, small multidirectional rockets will be used to help tighten the tether. After the continuous 36,000 km superlaminated graphene tether is connected from GEO to Earth, and the 256 cylinders are deployed from 36,000 km to 100,000 km. Then the second assembly machine, kilometer 100,000, will be welded to the last cylinder, and it will also begin to receive 4 rolls containing 500 km of superlaminated graphene tether until completing 50,000 continuous additional kilometers. The design of this climber is for cable-type tethers. It has 16 motors on the transport frame. 8 of them press the tether from the outside to the inside in opposite directions to provide better traction, and in the center there are 8 tank crawler-type motors. The chassis is made of carbon fiber or better material that is light, strong and withstands the space environment. It is also designed to carry 4 containers. This climber can carry 4 containers and the dimensions of the containers are 3.81 meters wide, 6 meters high and 1.78 meters deep. The transport climber has 2 climber variants that will provide energy to the cargo climber. One is the 2000 climber and the second is the nuclear climber. The climber 2000 is called the, since it will never go beyond kilometer 2000. It receives its energy by means of laser or microwaves sent from the nuclear silo, and this converts it into alternating energy. Important note: the reason why it will not pass 2000 kilometers is due to the terrestrial atmosphere that can interfere with the delivery of laser or microwave energy. The nuclear climber is composed of 2 huge nuclear piles, and due to its weight it will never drop below 1,500 kilometers. Important note: this climber will accompany the cargo climber up to kilometer 36,000. Everything will start on Earth, either using the nuclear silo or using the marine platform. A satellite dish located at the bottom of the tether will send energy in the form of a laser or microwave to the climber 2000. The climber 2000 will receive the energy, and since it is in contact with the cargo climber, it transfers energy to it, and together they will ascend until they reach near kilometer 2000. Due to its weight, the nuclear climber will never go below 1,500 kilometers, and in this presentation we will say that it will be waiting for the cargo climber at kilometer 1800. With the help of special sensors, the cargo climber and the climber 2000 will slow down as they get closer to the nuclear climber. Once the climber 2000 and the cargo climber come into contact with the nuclear climber, the cargo climber will be attached to the nuclear climber and the climber 2000 will disengage and return to the nuclear silo, while the nuclear and cargo climbers continue their trip to kilometer 36,000. After 8 days, the nuclear climber and the cargo climber will arrive at kilometer 36,000, where 8 autonomous robots will be waiting for them. Of the many autonomous robots that will be working in space, 4 of them will receive the cargo from Earth and take it to any project that is being carried out anywhere in the Earth's atmosphere. Be it the construction of a solar farm in GEO, a space station or supplies, and to a colony L5. And another 4 autonomous robots will load the climber with merchandise from space to Earth, whether they are empty containers or waste from these projects. Above the first assembly machine that is located in GEO, there will be 64,000 kilometers composed as follows: 256 separate cylinders each, by 250 kilometers of cable that can be Xylon, carbon nanotubes or another fiber of better quality. At kilometer 100,000, we will find the second assembly machine welded to the last cylinder that comes from GEO until kilometer 100,000. From the assembly machine, a new super laminated graphene cable of about 50,000 kilometers long will come out. According to this information, a tether above 100,000 kilometers will help us to conquer the solar system without using old fuel rockets that pollute the environment. It is for this reason that welding a second assembly machine to cylinder 256 located at kilometer 100,000 would be the solution to go to the Moon, Mars, asteroids, or any planet in our solar system. Once we have the additional 50,000 kilometers of graphenose super-laminated tether, a series of climbers could be installed near the end of the tether, which would serve as a warehouse to store supplies and luggage used by astronauts on future missions to the Moon and Mars. The ships will take off from the surface of the Earth, and will arrive at this node at kilometer 150,000. And it will be the crew itself together with the autonomous robots that will help to collect and pack everything they need for their mission, and they will even refuel to go and return to their destinations. And the same would happen if you wanted to mine in the asteroid belt or go to the outer planets, since, at this distance, 150,000 kilometers, it is much easier to escape the Earth's gravity. And in the end, at kilometer 150,000, we would have the apex anchor, but this time as an added value, we will install an early search system for potentially dangerous asteroids to Earth. If you plan to develop several space elevators in the equatorial part of the Earth, it would be a plus to install these systems in the apex anchor, since they will always be rotating the Earth 24/7.